So again, I'm going to quickly recap Arrhenius, modified, and then jump into writing equations with all kinds of spectator ions. That's going to be the new piece to this lesson. We're going to have examples like sodium hydrogen carbonate. Okay? And we've got to strip off that sodium. That's an ionic compound that's going to split in two pieces. And we've got to get comfortable with dropping the pieces that aren't acids, that aren't bases. But we're going to start at the very beginning. So Arrhenius acid, we've seen this example a few times. Arrhenius's definition is substances, acids or substances that produce H+ in solution. So this is the simplest description of an acid. Still used today, but not complete because we don't actually get an H+ ion in solution. Modified theory says it reacts with the water. Arrhenius bases are substances that produce hydroxide in solution. I didn't put the state in. I'm just going to leave empty brackets there. You could see solid, okay, or you might actually see aqueous written in those brackets. It's kind of whether you're talking about before you put the solid in water or after you put the solid in water and before it's broken up. So you have to be a little okay with either state being there. It's really the same thing. AQ, solid, is sort of semantics, but before or after it's put in. So that's Arrhenius. A better description, a more true description, is this transfer to water. And we're going to start seeing some more complicated examples. So you might have something like NaHSO4. Again, that could be a solid or it could be aqueous. You put that into water, and that's an ionic compound. Before any modified Arrhenius can happen, it's going to dissociate. So this is going to be kind of step 1 of 2, a precursor to my acid-base reaction. This is going to produce sodium ions and HSO4, which is a -1 charge, AQ. Sodium ions are not acids or bases. There's no way sodium ions can donate an H. They don't have any. And sodium ions are not going to make any hydroxide. You're going to see group 1 metal cations and group 2 metal cations are never acids and bases. We're going to be dropping those and using the other pieces consistently throughout this lesson and unit. So that's the piece, that's the acid or the base. Okay? And I'm telling you, or this is under the acid section, we're going to treat that piece as an acid. So now I'm doing the modified Arrhenius. There's our acid. Modified, it transfers to a water. Okay. This would not be part of your answer, but it's a visual aid that H is going from the acid to the water. This is where we get hydronium. And we're left with 1 S, 4 O's, and the charge is going to drop 1 when it loses an H+. So it's going to drop to 2-. So you're going to be given chemicals in this course. You're going to be given some information of whether it's an acid or a base. Okay. I might tell you it's an acid. I might say blue litmus turns red. I might say its POH is 8. Okay. Any type of information could be told to you, and then you'd have to write the equation. So 1 was the dissociation. We don't always have to dissociate it, but because we had something ionic, I did this first step and broke it up. Then I was ready to do the acid and base. The same thing can happen with bases. And I wouldn't have done examples like this yet. Phosphate is a base, PO4 3-, but you can't buy a bottle of phosphate. Okay? So I have some spectator ion, positive ion to go with the phosphate. So we have Na3PO4. You put that into water. It's going to dissociate. This is why we had to learn about dissociation first. Okay. We're going to get 3 sodium ions and a phosphate ion. Now, a lot of these equations are going to seem a little tricky because we're getting these ions you may not be used to. You're going to see these same ions showing up over and over again, and you've got an acid-base table in your Chem 2030 data booklet. And you're just going to see these same chemicals over again. So phosphate in this acid-base table, you've got an acid column, a base column in your data booklet, and phosphate is way at the bottom of your Chem 20 booklet, PO4 3-. So because I had something ionic, I did do a first step of breaking it up. You see a group 1 or group 2 ion, you're like, okay, that's not my acid or base. So the other piece must be your acid or base, okay? Even if it's something that's not in your table. So phosphate, PO4 3-. Modified Arrhenius equations are with water. Okay. Now the hydroxide in modified Arrhenius comes from the water. The water is going to get ripped apart. Okay. Bases are going to take in an H. And when you remove an H+ from water, you get hydroxide. So I'll write that first. There's the leftover pieces from the water. And our phosphate base gains an H, still has a P, still has 4 O's. Now the charge is going to change in the opposite direction compared to the acids. So our acid in our sulfate, the charge went down 1. Here the charge is going to go up 1 when the base gains an H+. So this is going to be 2-. Okay. So that's a modified Arrhenius equation for a base. Okay. This looks different than the group 1 and 2 cations with hydroxide that we saw previously. So that's some examples of what we're going to do in practice, getting sort of written steps instead of oral. Okay. So in order to write a modified Arrhenius equation, be it for an acidic or basic species, okay, we need some information about the chemical formula. We may have to remove some spectator ions, or you'll be doing that in probably 80% of the questions. Okay. And then as mentioned earlier, I have to give you some information about whether that species is an acid or a base. Okay. So again, this may look like you have sodium carbonate, okay, and the POH is 2. That would cover both of those bullets. So an example, I could give you that formula. And then tell you something about the POH. And from that information, you should be able to break up that sodium carbonate, realize it's not the sodium, do something with the CO3 2-, pOH of 4 means the pH is 10, and a pH of 10 would be basic. So I'd expect you to write a basic modified Arrhenius equation. So steps, how sequentially, how you're going to take that information that's given, information like that. The first thing you're going to do is an if statement. You're going to do a dissociation if it's ionic. Okay? And you're going to do this most of the time. And some of you might get stuck when something's not ionic. You get so used to breaking something up, you don't know what to do. And you just don't do anything. You just jump right into step 2 if it's not ionic, if it's a molecule. So I've been labeling that step 1 in my notes up above. And then second, which I was labeling 2, do that modified Arrhenius equation. And then just getting it in notes. This is going to save you so much time. Okay. Realizing that group 1 and 2 cations are never acids or bases. Step 1, that dissociation is something that many of you will just start doing in your heads and not writing out when you're practicing problems. So the first example that I'm going to do is we're asked to write an acid-base equation based on the information given. I didn't put in the wording, but I'll be writing modified Arrhenius equations. So we have a basic solution. That's kind of that second piece of information we needed. We need the chemical, and that's sodium sulfate. So I'm going to write out the dissociation. Okay, it is ionic, so I'm going to do step 1. Okay. We got 2 steps. Sometimes one gets skipped. So sodium sulfate, Na2SO4. So you'd probably start with the anion first. Sulfate is in your data booklet. It's a 2-. Because it's 2-, I had to put in 2 sodium ions. I'm going to switch colors. You don't have to write this in the dissociation, but your brain has to realize that's 2-, and that's a +1 cation. So you get the subscripts correct. So it's not the group 1 or 2, it's the sulfate, SO4 2-, aqueous plus water. Then we got to slow down. What is this? It's a basic solution. So our ion is going to gain an H. It's going to rip water apart. So when it rips water apart, we get hydroxide, and we add an H to our sulfate. And the charge goes up 1, so it's just a -1 ion. Now, if you're having any trouble remembering what to do charge-wise, not all the time, but a lot of the time, the species are going to be in your data booklet. So sulfate is in your Chem 2030 booklet in your acid-base table. And when it gains the H, you've got the HSO4 in the acid column with the correct charge. Okay? And you always have this for tests or quizzes. So this can be a bit of a double check that you're doing the charges right. So that's our first one done. Second example, an acidic solution of sodium dihydrogen phosphate. This is probably going to be as tricky visually, but if you just follow the steps, it's not tricky. So first thing, that is an ionic compound. What makes it jump out to me as being ionic is the fact I have sodium. That's a metal ion. Okay. And that could be a solid or aqueous, and then we do the dissociation. Only ever dissociate into two pieces. So you're looking for the metal cation and then the anion. Okay. So that's going to be our split. Okay. Students get in trouble when they try to start splitting everything up. I'm going to take out that red line. Do not put that in your notes. That's incorrect. Okay. The correct split, cation, anion, is just the blue. The green. So we have our species that must be an acid because we're told we're going to get an acidic solution. So H2PO4 minus is going to react with water, liquid water. That's an acid. Acids are going to lose an H and make hydronium. Send 3 H's to water in total. So the dihydrogen is going to go down to monohydrogen, just 1. The charge is going to drop by 1. And again, if you were doing this yourself, both of these green dotted underlined species are in your data booklet to kind of double check charges if you weren't sure. Work on. Okay. A solution of ammonia has a pOH of 4. Now, ammonia is an incredibly important industrial chemical, particularly in fertilizers. It shows up in Chem 20 and 30 questions all the time. And its formula is NH3. It's something I'd want you to get used to. You really have to watch the wording, and I have to watch when I speak. There's ammonia, which is on the board. There's ammonium, which is NH4 plus, and that's in your polyatomic ion table. So when you see this AMO, look at the ending. There's 2 similar endings. pOH of 4. This is where I made a comment in a previous lesson. My brain works better in pH. So I'm going to switch that. 14 minus 4 is 10, and 10 is basic. I could think this through in pOH, but it'd take me a little while longer. Okay, low pOHs are basic, below 7. Okay, is NH3 an ionic compound? No, it's not ionic, so there's no step 1 to do here. We're ready to jump right into ammonia. All our modifieds are with water. We have a basic solution, so it's going to gain an H. It's going to rip water apart and make hydroxide. Okay. Your brain might have some bias, and it sees NH3, and it's like, oh, it's going to lose one of those H's. No, it's not. It's not an acid. Don't take an H away. We're actually, ammonia will pull an H out of water, an H plus. So that's ammonia in the question. This is ammonium in your polyatomic ion table as the product. Visual to guide what happened is going from water to the base would be part of an answer. Your brain setting yourself up for success, an organizational tool. I wouldn't mark it wrong if you put that arrow in. I just kind of totally ignore it, and I look at your equation to see if it's proper. You must have proper charges to be correct. Okay, you can't leave them out. Okay, you'll get deductions. So let's see how well you're doing with some practice. So I've got 3 different examples for you to work through, and in a few minutes, maybe after you worked for about 2 minutes each, I'll just put up the modified Arrhenius. I will skip the dissociation in terms of putting up the answer. So the solution to A, just the modified Arrhenius equation. I look at sodium carbonate, and I'm not going to do the dissociation out. My head is like, there's sodium. That's not what I'm after. Okay. In step 2, I'm just going to jump right to the carbonate. Okay. If I wasn't sure its exact formula and charge, I'd go look it up in my table. That's going to react with water. pH is 9, so that's basic. So the carbonate's going to gain an H. And the water is going to lose an H. It's going to be OH minus. Now, the order that you write the products does not matter. I tended to write the hydroxide first. Previous in this lesson, I wrote it second. These pluses are really the word and. The order doesn't matter with the and. You get hydrogen carbonate and hydroxide. So that's the first one. So going through the answer for B. B is a much trickier question. A was just like the previous notes. B, we've got ammonium nitrate. We've got 2 polyatomic ions. So I will write out the dissociation for this one. Ammonium is NH4. Nitrate is NO3. We don't have any metals, but this is still an ionic compound because we have a cation, we have an anion. That's going to dissociate and give us NH4 and NO3. And just looking at the dissociation, you're not sure which one species is going to continue, but you had to, okay, we know acidic. Have to donate an H to the water. That's where the hydronium comes from. So our first species could potentially be an acid. You're not sure, but it's got an H. But if you look at nitrate and really understand the nature of acidic solutions, nitrate cannot donate an H. It does not have one. So that has to go out as your possible acids, which you're not sure, but the only thing that could be your acid is ammonium. And it is, in fact, an acid. Now, you have a little bit of backup in your Chem 2030 acid base table. NH4 ammonium is listed as an acid. Okay, but you didn't need that. The question tells you we have an acidic solution. Then you can take your NH4 plus. You can donate an H to water. Water is now hydronium. And ammonia keeps its N, but its 4 H's drops down to 3. And the positive goes down to neutral, so you don't have to write a charge. We're very used to seeing anions show up in our chemistry or neutral compounds. This is one of the very few positive species we see anywhere on our acid-base table. So the fact we started with a cation is unique in this question. So A would be pretty straightforward on a test or quiz. I deem that a question almost everybody should be getting right. B, a little trickier. C, different style of question. This really tests, can your brain keep the two definitions, the modified Arrhenius, modified Arrhenius acid, modified Arrhenius base within the same question. I'm going to write two equations. The first one is going to be acidic, and the second one is basic, and we're starting with the same chemical. Okay. So if this is our acidic example, we are transferring an H away. So we're going to get our hydronium. That's the first thing I look for when you write an acidic equation is, do we have a hydronium product? And HPO4 2- has one H. It donates it away, so it's going to have no H's left. Drop the charge by 1. As a basic equation, now your brain has to be able to go the other way. Bases are going to take in an H and make hydroxide when it takes it from water. We get H2PO4. And it was 2-, it's gaining an H+, it's going to drop to minus. Okay. So we have, these are the two equations, one acidic, one basic. Okay. Now one of these is going to dominate. We're going to pick up from where we leave off in Chem 20 into Chem 30. And in Chem 30, we could compare these two. The last column in your acid-base table is K values, Ka, the equilibrium constants for acids. We'll learn in the next level in Chem 30 how to use these. Okay? So right now you're ignoring those right now. We're not going to figure out which one is stronger or dominant. Okay? So that wraps up writing modified Arrhenius equations. The next skill that's coming in the following lesson is looking at polyprotic species. Poly means many, and protic is H+. Species that can donate many H's or accept many H's. We looked at something like a phosphate PO4 3- ion as a base, and the fact it's 3- actually allows it to gain 3 H's. So we'd have to write 3 separate equations. Okay? So that's your preview of coming attractions. That'll be in the next lesson / video.